Hello everyone, this is Professor DePaulo. Welcome back to Psych 220 Behavior Statistics. And I'm going to be going through the correlation and regression example problem. So in this problem, we're looking at the relationship between study hours per week and exam scores. So we're going to first calculate the correlation coefficient between these x and y variables. So the first thing I do here is we're going to call this x, study hours per week, and the exam scores are y. I would also want an x squared column. I'm going to want a y squared column and an xy column. So squaring the study hours per week, this might be a little bit, actually I'm going to spread it out a little bit more. These numbers is a little too close here. So let me write it out. So study hours and let's do exam scores. You have to line it up. If you don't line it up, you're going to make mistakes. So make sure you line these data up. So those are my x and y, study hours and exam scores, right? This is my x, and this is my y. I want an x squared column. I want a y squared column, which is going to be a little bit more for me to compute here compared to the x squared column. Let me just copy and paste that over here so I can just copy it. I don't have to go back to it again and again. And the numbers get big pretty fast, so you have to be careful here. So that's my y. And let's do an xy here. And I'll do the sums afterwards. Let's do study hours times exam scores. That'll give me my XY column here. Now that I have all those columns set up, I can now find the sum of all these columns. I'm just finding the sum of all these columns here. So those are my 5 answers here for my 5 columns. That way I don't have to go back and forth and keep switching. So the sum of x is 44. The sum of x squared is 685. The sum of y is 272. Oh, that is not, yeah, that's not gonna look good here. So it doesn't actually look right. So let me go back and check this. Because the 272 does not, it's obviously wrong. Sum of exam scores, oh, second one. That's why I put it in the wrong order. So don't do that. Don't put it in the wrong order. Because if you put it in the wrong order, you're going to be in trouble. So study hours is first. Then the next column is study hours squared. Then the next column is exam scores. Then the next column, forgot the bracket here. The next column is exam score squared. And the final column is study hours times exam scores. And that's going to look better. So I wanted to make it easier and end up making it harder because I put it in the wrong order. So this value is obviously not that. So this value is 272. That's going to make more sense. So 685 here. This one is 52,975. And this column is 3505. So you got some big numbers there. Now we're going to do the correlation. So correlation, I need to find the SP value on top. So correlation is R is equal to the SP value, which is sum of the products of the deviation scores. Sum of the product of the deviation scores over a square root of sum of square X times sum of square Y. So let's find the SP value. That's going to be the sum of XY minus the sum of X times the sum of Y over the number of pairs of scores. Just going to check to make sure that formula is correct. Let's get the formula sheet out again. That is in study guide. That formula is correct. So let's find that. SP, sum of XY is 3505 minus sum of X, sum of Y. Number of pairs of scores, 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of scores. So that's 3505 minus this product, 44 times 685. $44 times 685 divided by 9. So that's minus 3348. 334889. So let's look at that again. 3505 minus 3348.89 gives me 156.11 for this. That is your SP. Now to find sum of squares of x, that's simply sum of x squared minus sum of x quantity squared over n. So that's going to be 272 minus 44 squared over 9. .44 squared over 9 is 215. 272 minus that value. Let's just solve it. 56.89. That's sum of squares of x. We want sum of square of y, the sum of y squared. Minus the sum of y quantity squared over n. That's going to be 52,975 minus 685 squared over 9. Let's do that here. 52. $838.89. So that's sum of x over y, so I can solve this now. This is 156.11 on top. This is square root of these two values multiplied together. 56.89 times 838.89. So R is 156.11 on top. I don't know what the product is of this. Let's look. 56.89 times 838.89. Let's do the square root of that. So I'm just going to skip that step and do the square root of that product. And that's going to be 218. So when I solve the whole bottom here, I get 218.46. And when I solve this, I get 156.11 divided by, I get 0.71 as my correlation. And then I check that in R simply by putting core and the two variables in. Exam scores, comma, study hours. Doesn't matter what order you put them in. And that's correct. So that's my correlation. Now once I have that correlation, I can do the regression. So let's do the regression now. So regression is prediction. So I'm predicting exam scores based on study hours. So let's do that. So I know that the regression line is Y predictor equals bx plus a, where b is the slope and a is the y-intercept. To find the slope, it's sp over sum of squares x and these are in the formula sheet. And then to find a, it's the mean of y minus b times the mean of x. The mean of y minus b times the mean of x. So I need those means. So let's go find those means here. Let's get rid of this. I don't need that. So let's do means. So the mean of x is simply sum of x, which is 44 over 9 which is 4.89. And then the mean of y is simply 685 over 9. $76.11. So now that I have those, I can plug in here. So let's do the slope first. Slope is SP, which is 156.11, over sum of squares X, which is 56.89. And we solve that. .74 as my slope, and then the y-intercept is mean of y, which is 76.11 minus the slope, which is 2.74 times the mean of x, which is 4.89. So that's 76.11 minus that product, 2.74 times 13.40 rounded. $76.11 minus 13.40. $62.71. So that's my slope, that's my y-intercept. So the line becomes b equals the slope 2.74 oh sorry, not b, y for the line. The y predictive is the slope 2.74x plus 62.71. That is my regression line. And I check that here by doing something like this. Linear model, we're using exam scores predicted from study hours. So we see a little bit of, the y-intercept is 62.69. We have 62.71. That's rounding error. Slope is fine. So we're off by a little bit of rounding error. But that's the That's good enough for the regression line. Let's do the scatter plot. I'm going to plot it here first. Study hours and then exam scores. That plot looks kind of small here. There we go. It's kind of spread out here. How does that look if I draw the plot? So I'm going to draw a really sloppy plot here. The X is easy because it's 1. The range of X is 1 through 9. So that's easy to label. And those are study hours. So you just make 1 through 9 here. The best you can. Now the y-axis is a little bit harder because it's starting at 65, starting at 60, ending at 90. Start at 60. I'll go up by 5, I guess. 65, 70. And this is just, do the best you can here to label this. So this is study. Yikes. Screwed that one up. So this is study. And this is exam scores. Okay, now I need the raw data. So 365. Let's make this a little smaller so I can do this. So 365 is here. 470 is about here. This doesn't have to be perfect. 680 is about here. So I'm just plotting the points that we have. 990. What else we got? 885. As you can see, this is very close to a straight line. 260. We're almost on a straight line. 570. 685. 180. So that's your real outlier here. But the line, the points are pretty straight. It's definitely a positive correlation. It's going to be a positive slope for the regression line. If I want to draw on the line, I need 2 points. 1 point could be the y-intercept, where it crosses the y-axis. That's easy to find. That's A, 62.71. So I can mark that as my y-intercept here. Somewhere here, I'll make an X. And I want a point on the other side of the curve. So let's do 8. Take 8, plug it into the regression line. So 2.74 times 8. Plus the y-intercept, which here is 6271. That's 84.6, so that's my second point on the line. So 8 and 84.6 is like right here. Take these two lines, take these 2 points and connect them. You have a very close line. I mean, all the data points are close to this line, with the exception of one, which is more of an outlier. But everything else is kind of close to the line. So that would be a regression line. if we were to predict 7 hours sleeping, so all I have to do is plug in 7 here. So it'd be predicting of 7 would be 2.74 times 7 plus 62.71. And when I do that, plus 62.71, 81.89. So for someone with a that studies 7 hours a week, their exam score is 81.89 based on this regression model. So that's pretty good. And obviously, the more you study, the better your exam score is going to be. And that's it for the correlation and regression problem. So set up the problem with the columns. You want 5 columns just like this. You got to do the squaring. You got to do the squaring for x squared, squaring for y squared, and multiply x times y column for the xy column. You get the sums of all those columns. You then calculate SP as sum of xy, which is this column, minus sum of x times sum of y over a number of pairs, which in this case is 9. You solve that, that gives you SP. That's the top of the correlation. The bottom is square root of SSX and SSY, so you calculate SSX here. Sum of x squared minus sum of x quantity squared over n. So that gives you SSX. Then you get SSY. Multiply them together. Take the square root. You get 218.46. Divide. You get 0.071 as the correlation, which is pretty strong. Very strong, actually. To get the regression, y prime here is bx plus a. Find the slope. SP over sum of squares x, so it's 156.11 over 56.89. That gives you 2.74 as a slope. It's a positive slope. Then to find the y-intercept, so this is a equals the mean of y, which is 76.11, minus b, which is 2.74, times the mean of x, which is 4.89 right here. Solving that gives you 76.11 minus 1340, and you get 62.71 as the y-intercept, which is a. You then write the regression equation, y hat equals the slope, which is b, x, plus the y-intercept is a, so that's the regression line. And then to find a value on that line, if you're predicting something, all you do is plug that value in for x and then solve for y again. And that's the predicted value. And you're done. That's correlation and regression. So hopefully that helps. And if you have any questions, feel free to reach out to me and I'll try my best to help you. So bye for now.